So good afternoon and welcome to the 16th session of the Creativity and Innovation and Inventive Problem Solving course. And we will start today with a quick review of various tools related to TRIZ that we have understood till now. And then I will talk about another tool, which is called as Trends of Engineering System Evolution today. And then we can break out into our rooms and work on our projects. Is that okay? So the overall tool set that TRIZ offers to us has been divided into three major parts. The first part is problem identification. The second part is problem solving. And the third part is concept substantiation. So in the first part, which is problem identification, which all tools did we work on? Who can tell? And also, why is this stage important? Problem identification stage. Why is this important in the first place? I will wait for your answer.
Here we analyze the functions and we can rank them, and we do stuff like CEC and trimming and all.
So तुमने बहुत सारी चीजें mix करके बोल दी सौम्यदी. So yes, the first tool that we looked at in the problem identification stage was CECA, cause effect chain analysis, which is very similar to root cause analysis or fishbone analysis or 5 whys kind of thing, where we go deeper into the problem statement. Okay, we see that there is something which is not happening the way it should happen, and we see that as a symptom of some problem which is deep rooted in that engineering system there. That is why we start to ask why is this happening, and we build those CACA diagrams, cause effect chain analysis diagrams we build. So what kind of disadvantages would we ideally want to work on? The initial disadvantages or the key disadvantages?
So the key disadvantages.
How are key disadvantages different from initial disadvantages?
So initial disadvantage is like the cause of that key disadvantage. Like that key disadvantage happened like is in the system, and due to that after like few iterations of going forward, we reach the initial disadvantage that we might see when we are just starting off with the problem. So in our ability to solve the key disadvantage, we would be solving all the the disadvantages that would come after due to that.
So why is this thing important? Why is it important to go to key disadvantages? So one thing you said, Lavanya, that okay, by solving the key disadvantage, you will solve all the subsequent actions. But मैं पूछ रहा हूँ कि यही क्यों जरूरी है? If I simply see सिर में दर्द हो रहा है तो मैं बस सेरिडॉन ले लूँ. Why go deeper into it?
So I believe since we are making a product or like a solution to something, we can obviously do that, that we solve the initial disadvantage at that tip of the tree and don't go deeper into the root. But later we might find out that there might be some other cause, that some other problem that might be causing due to that initial disadvantage, which we could have nipped at its root only and not have that penetrate later into our system.
So thank you, Lavanya. So yes, this is important because a key disadvantage may lead to many subsequent symptomatic disadvantages. So one key disadvantage can actually lead to many initial disadvantages. If we dig deeper, then we may find that overall everything can be solved by just solving one key disadvantage. So एक तीर से बहुत सारे निशान. Then second thing is that the initial disadvantage might be difficult to solve. might be huge in its dimension, because it has taken, it has built upon the key disadvantage, and it has grown into size. So it may be very difficult or humongous to solve. Whereas if we go a bit deeper and we understand where the key disadvantage is, the solution may be inexpensive. So that is also one more reason why we want to look for key disadvantage. So in fact, this also answers the first question that I asked: why is the problem identification stage important? So who will, like मैंने बोल दिया वो answer अभी, लेकिन who will rephrase it for me? Why is the problem identification stage important in any problem solving process? Yes.
So basically, before completely analyzing the problem and digging deeper into it, we cannot actually find the solution for a problem. So it's very much necessary to spend a sufficient amount of time in identifying the problem properly so that we can work on the solution furthermore.
Good. Thank you, Malika. So yes, very right. If we spend time on the problem and understanding the problem, then we can arrive at a better answer. This problem identification stage is very similar to, let us say, the first stage of 6 hats, where we wear the white hat and collect lots of data, information, ask questions, find answers to those questions. So that white hat is the first hat that we have to wear when we enter into problem solving stage. More importantly, as I just shared, the first disadvantage or the initial problem that we may observe may be very big and huge, and we may find it difficult to solve it. However, by spending time in understanding the problem, looking at it from different perspectives, function model, CECA, so many different things we did, flow analysis, we may be able to identify much simpler problems which led to the big problem. Much simpler disadvantages which led to the initial disadvantage. And solving those simpler disadvantages, there could be a technology that already exists within your organization. There could be a technology which already exists in openware somewhere, and you could simply use it. Whereas the initial disadvantage can be huge, or the initial problem may appear to be much bigger. The solutions for those simpler problems could be very simple and can be like low-hanging fruits. So that is why it is very important to spend sufficient amount of time in problem identification stage. So we talked about CECA as one tool of problem identification. What other tools did we talk about? What other tools have we discussed in this class for problem identification?
So functional analysis, flow analysis.
Function analysis, flow analysis, yes.
We also did the trend analysis, like in short, like evolutionary. You just told us in bit, a little bit.
आज करने वाले हैं लावण्या.
No, you said a little bit about it in the class though.
थोड़ा सा करा था, but yeah, we'll handle it
not
in
properly, yeah.
Today.
Yeah. We also did benchmarking and 9 streams and feature transfer.
And we also did trimming.
Yeah, trimming, obviously. Yeah.
So trimming completely changes the problem statements that we are trying to handle. Like that paint filling system example. You trimmed everything, and all that you needed to do was just turn the barrel upside down. So problems can become very simple problems, much easy to handle problem can appear, and that can save the day for us. So that is what we do for problem identification. So good. Then the next stage we looked at was problem solving. So which all tools have we looked at for problem solving?
So inventive principles.
Inventive principles, and they can be applied through 2 ways. So how many inventive principles did we talk about? Did Altshuler propose? और चलो propose भी किया,
40 inventive principles.
40 inventive principles, and we apply them through 2 or 3 different methods. Which are they?
So physical contradictions and technical contradictions.
Physical contradictions and technical contradictions. Technical contradictions are simpler to implement because there is this lookup table. How many parameters in the lookup table?
39 cross 39.
That's a 39 cross 39 matrix where some generic parameters are given. We call them as typical parameters. So whatever problem that we are facing in our engineering system, we translate that into a typical engineering contradiction and then simply use that lookup table to identify which inventive principles can be most favorably used to solve the problem. The other way is physical contradictions. So physical contradictions, how do we solve physical contradictions?
So we start by the method of separation in different like parameters, in direction, in space, in relation. Then we went to like separating them or solving them. And sorry, in the last we did like solving them or satisfying them individually if we cannot separate them, which was like, and after that I thought we did something like, or I think it is the same as completely changing the paradigm.
Bypassing the contradiction.
Bypassing the contradiction.
Bypassing, yeah, exactly.
Yeah. And for each of these, separation in time, separation in space, separation in relationship, we had inventive principles which can be most commonly used, most easily used to bring about that separation.
Yes, sir.
Great. So then that we looked at physical. What other tools did we talk about? So inventive principles is one which are applied through technical contradiction matrix and by using physical contradiction. What other tools did we use or did we talk about?
Standard solutions.
Standard solutions, which are like substance field diagrams.
Yeah.
Can you just
function-oriented search?
Me with? Sorry, Samadi.
Function-oriented search also.
Function-oriented search. So what is function-oriented search?
It was like I don't remember properly.
Anyone else?
Like we see the existing what exists in similar situations or like similar industries.
No. So we look for similar functions and we look for how they are performed in the critical or the leading industries. And we saw that leading industries are typically defense and medicine because they are life critical. So how are these things solved there? And that is what we look at. Same technology can we apply in our context because the function is same. Can I apply the same technology in my problem context because the function is same and therefore save on R&D costs? I can have faster time to market. That is function-oriented search. We looked at the example of those nasal filters where we saw that industrial air filters have the centrifugal mechanism through which particulate matters stick to the walls of the chimneys. We said we can do similar thing with our nasal filters there, where the structure of the filter can be designed in such a way that the air as it enters the nostrils runs through the filters and the particulate matter can be attached to the lining of the filter there. So what other tools? Solution finding tools. So we are yet to look into what is called as TRIZ, which is algorithm for inventive problem solving. We are also yet to look at small little people and library of scientific effects. Okay. So we will look at those aspects very briefly in the next few lectures. Today, we will look at, as I mentioned, one tool in the problem identification stage, which is trends of engineering system evolution. In the concept substantiation stage, do you remember what all tools we mentioned? I mentioned to you then those tools to you. You have not touched them yet, but do you remember any one of you? So there are tools like super effect analysis and patent circumvention or patent analysis, which we can use, which we can look at in the next few lectures. Again, very briefly, not in too much detail, because I want you to focus on your projects. So we'll spend some time on the projects in every class, but those tools are there. Okay. So today we are going to look at trends of engineering system evolution. What do you remember? What are these trends about? What are these trends about? कोई तो बोलो. I'm waiting. I'm not moving to the next slide until someone answers. तुक्का ही मारोगे, लेकिन कुछ तो बोलोगे.
So I think I don't remember properly, but I think we talked about analyzing how the trend of certain thing is going on already in the market and might maybe applying it to our system. I don't properly remember, to be honest.
So we were looking at trends of engineering system evolution are basically trends how engineering systems have evolved across industries and across dimension. मतलब छोटा engineering system हो चाहे बड़ा engineering system हो, there are trends which engineering systems follow as they evolve over time. And if we know these trends, then what is the benefit that we can derive out of it? Suppose you know this is how this engineering system will develop over time. So what benefit can you derive out of this knowledge?
We can be prepared for that, or we can develop a product in alignment with that.
Suppose you know that your R&D will take about 1 year or 2 years. You are in this stage. This is how this technology would evolve. This is the way it has to evolve. This is the way it has been evolving. And you can already start to work on that so that you intercept the 2 years of R&D that you're going to do. After that, when the product comes out, it is not obsolete on the first day of entering into the market. You don't want that to happen, is it not? You want to remain relevant. That is one aspect. Second aspect is that when we talk of, let us say, minimum viable product in our entrepreneurship journey, this is where we are today. What should be our next step? Trends of system evolution can help us identify the next step. Another aspect is, suppose you want to protect some invention that you have. You can already anticipate how the system would evolve over time, and already have such clauses that the patent claims are future proof. Or you could file 2 extra patents. You do not have a demonstration of them, but you simply file them because you know that this is how the technology would anyways evolve. So you have kind of protected your growth path. Otherwise, a new startup would come, they would protect the future one, and then you are gone. Are you able to see this?
Yes, sir.
So trends of engineering system evolution are statistically proven directions of engineering system development. They describe the natural transition of engineering systems from one state to another. And these directions are statistically true for all categories of engineering systems. So what is the difference between statistically true and true?
So by statistically true, we mean that the truth we have estimated from various metrics, while truth is generally the ground truth, the reality, which we don't have any means of measuring, I think.
Yeah. So I cannot really estimate what the future would be like, is it not? So अगर वो पता ही होता तो मैं तो फिर जानी जान हो गया, मतलब मैं तो फिर भगवान बन गया, is it not? I do not really know the future, how the things would evolve. But by looking at how the things have evolved in the past, I am giving you a statistical, a confidence interval that, okay, 95% confidence, this is how the technology will develop. Now that is a 95% confidence. And even then, as you will look at the trends as they are listed, they do not really enumerate, they do not really tell the path of this evolution. They simply say this will happen. How it will happen, who will make this a reality, we do not know that. Somehow it will happen. How, we do not know. So that how is where our creativity lies. That how is where you and I would brainstorm, would ideate, would propose solutions, and then depending on which solution hits with the market, with the product, that solution will become the reality. Other solutions will die of a natural death. Many times you will see that many solutions would coexist. Many like an engineering system would coexist in multiple stages of evolution simultaneously because of market needs, because of customer requirements. We will discuss about that also. And statistically true also means कि this will happen. किस time frame में होगा वो भी नहीं पता है आपको. तो आप estimate कर सकते हो, but there is a confidence interval that we're talking about. We should not consider them as gospel truths. Is that okay? So this is a disclaimer. Before even introducing the subject to you, this is a disclaimer. You don't consider this to be gospel truths. Use these as directions for your ideation process. Okay. So there is a hierarchy of trends. And the top of the hierarchy is trend of S-curve evolution. How many of you have heard about S-curves? You can raise your hand if you have heard about it.
Sir, can you repeat the part about the confidence intervals you were mentioning in the last slide?
Oh, so what I was saying was that, see, a truth is a truth. You do not talk about confidence interval there. You do not say, ye aisa hoga with 99% or with 80% certainty. If it is truth, it is the truth. For example, if you sow a mango seed, mango की गुठलियां आप लगाओगे तो उसका आम का पेड़ ही निकलेगा. That is the truth. You do not want to talk about, or there's no point in talking about, oh, I'm 99% sure इसमें से mango का tree निकलेगा. Do you talk about it like that?
No, sir.
No. So that is truth. That is a universal principle. Whereas when we talk of these trends of, trends of engineering system evolution, these are trends. You will see that at times, the trend will be the same, but as I said, multiple stages would coexist because they have a different role, different purpose. So there is a statistical truth behind it that, okay, 99% of there's a 99.99 probability that this is how the system would evolve. in 2 years. Now, it may not evolve in 2 years like that. It may evolve in 5 years or 10 years. So, आप अगर 2 years मान के आपने एक solution बना लिया, market testing नहीं करी, सीधा market में launch कर दिया, it may not work because the other ecosystem is not ready. Those of us who watch movies, have you seen critics commenting on movies that, oh, this movie is ahead of its time, people are not ready to accept it yet? Have you heard such statements?
Yes, sir.
So that is where some mistiming has happened. So we know society would evolve like that. We have seen Western societies evolving, we have seen Eastern societies evolving like that, so we will also evolve like that, but we are not there yet. The movie is ahead of its time. Similarly, these trends of engineering system evolution, they are statistically relevant and statistically true. We've seen societies there, societies here, they evolve in such a way. We will probably also evolve in the same way. We have followed the similar trends earlier, but कब, किस time frame में, we can't say. So एक confidence interval की बात आ जाती है, confidence की बात आती है कि कितने confidence से आप इसको truth मान सकते हो. The only purpose to say that is, don't assume them to be gospel truths, but they are general, they will be followed. But किस तरह से follow होगा, उसके लिए कोई recipe नहीं है. Is that okay? Is it clearer?
Yes, sir.
So S-curves. How many of us have heard about S-curves? Looks like no one. So, I used S-curve to guide and mentor my juniors at ST in a very neat way. Let me show that to you also. Let us say this is the value you bring to the organization. This is let us talk about it starting from people, and then we will come to products. And this is time. So what happens when you start some new activity? Your value is very low. You're learning. Your contribution is low. Once you start to learn, once you start to contribute, after you have learned the activity, your contribution does not come down, but it largely saturates. Have you seen that? Suppose you are learning a new language, Python. आप सबको आती है. So initially, when you started to learn Python, you spent some time, you could not make programs. If I would ask you to make an app, you would take 2 days, 5 days, 10 days to make it. Am I right? But once you know, once you know what the app is about, or what Python is about, if I ask you to code something, you can quickly code it. So your efficiency starts to improve. But then after a point of time, your efficiency kind of saturates. You've seen that happening with yourself?
Yes, I mean, there are some systems where we observe the same, that, with time, the value just stagnate. I think there was this trend we were studying in computer architecture where we were talking about the number of the performance versus number of transistors on each chip. So it became like that.
Very good.
Yeah.
Thank you for pointing me there. Let us say clock frequency of your CPUs. When I was when I joined my engineering, at that time, 100 megahertz was the peak performance of the CPU. Then next year it became 150 megahertz. Next year it became 200 megahertz. Gradually bhi nahi, soon, fast enough, the frequency of CPUs reached something like 2.5 gigahertz. And do you realize that is where it has saturated? Even today, you talk about clock frequencies of that range, you just have increased the number of CPUs there. So what happened? Now the clock frequency, so we call it as main parameter of value. Initially, the main parameter of value was clock frequency. It was very low. You started to increase it. You were selling based on the clock frequency that was being talked about. But after some time, everyone talked about clock frequency. Everyone is giving the same clock frequency. So no one now talks about clock frequency. Now, what do people talk about? They introduced a new MPV, which is number of cores. So initially there were 1 cores, then 2 cores, then 4 cores, then 8 cores, then 16 cores. Then there are server processors with so many more cores. But then finally your mobile phones, etc., have kind of saturated at, let us say, 8 to 12 cores. Am I right? So this is the trend of S-curve evolution. That initially, for a very long time, there were only one number of cores there. Just one core used to exist, very long time. Then someone said, let me put 2 cores, 4 cores, 8 cores, 10 cores, 12 cores, and then it is kind of saturated. Now people do not even look at how many cores we are there. Now we start to look at other parameters of value. So what it essentially says is that any parameter of value, as you will evolve over time, will soon become a commodity. Before it becomes a commodity, you have to identify what is the next parameter of value where you should innovate and focus on. Are you able to see this? Why is this S-curve trend so important and for each one of us? Any questions? So when it comes to S-curve evolution, what the formal definition is, as an engineering system evolves, the evolution of each parameter of value describes an S-shaped curve over time. And different MPVs are usually at different points in their respective evolutionary development. The first stage is a very, very slow moving stage.
So can you show the previous slide once more, please? Just a second.
You have a question?
Thank you. No, thank you.
Okay. So the first stage is a very, very slow moving stage. Nothing much happens in terms of products. However, this is also the stage where a lot of innovation may be happening behind the scene. In the transitional stage, moving from one's first stage to second stage, that innovation may start to see productization. Some products would come out, you're doing market testing. You want to see which MPV or which direction the evolution of MPV is relevant. Once you cross this transitional stage, it is proven that this is the MPV that will grow next. And everyone innovates to evolve this MPV. The value of the MPV increases significantly. After some time, it becomes a commodity. It no longer is the reason why products are sold. And then after a long time, so don't assume this to be linear scale, okay? After a long time, you will see that this MPV actually loses its value. You do not want this MPV, you actually want to downgrade. Touch phones. All of us use touch phones today. We are in the third stage there. But do you also realize that there are people who say that, okay, I want to keep a regular feature phone with no fancy screen there. And that feature phone would have a battery which would last for 4 days or 5 days. Have you seen such things happening?
Yes, sir.
So it means that touch screen has entered the fourth stage also. Now realize, as I mentioned, products are in different stages of evolution and they are coexisting. Most of the phones are standard phones, touch screen phones, but the fourth stage has also arrived. It is evident now. That the fourth stage will arrive is sure. When it will arrive, we do not know. And whether third stage or the product at the third stage will be completely annihilated, unlikely. It may be, it may not be. Are you with me? Any questions?
So, sir, then what after the fourth stage?
Good. So जैसा मैंने कहा, you have to identify a new MPV. As you start to enter into third stage, your R&D team should already work on what is the next feature. The earlier you start your R&D on that second one, the faster your growth rate could be. Are you able to see this?
Yes.
Some teams started their R&D a little later, they hit the transition stage later. Someone started it earlier, they hit the transition stage earlier. Overall effective growth rate for the two companies can be very different.
Yes.
So we do not wait for the fourth stage to arrive. But yes, if you have a technology, suppose okay, so just like we did function oriented search, there is also something called as reverse function oriented search, where we say, I have this technology, where can I use this technology? So fourth stage में reverse function oriented search बहुत काम आती है. Let us look at this thing in a little more detail. So what are we saying? We are saying that a product evolves in the first stage, goes to the second stage where there is a high growth happening. Then third stage, growth kind of saturates in terms of the MPV, evolution of the MPV. And fourth, the MPV loses its steam. And then, there is a trend, there is a determined trend that when you are transitioning from first stage to another, which is where you are starting to industrialize and bring the product to market, the number of patents, you will see there is a spurt there. Then many companies would die off because their product did not work. Their inventions did not find liking of the customers.
So can you explain that patents wala thing वापस?
The number of inventions?
Yeah.
So क्या होता है? So let us say there was this MPV of increasing clock frequency. So initially बहुत सारे लोगों ने पेटेंट, बहुत सारी कंपनीज ने पेटेंट फाइल करे that this is how we would increase the clock frequency. This is how we would increase the clock frequency. This is how we would increase the clock frequency. Because अभी इंडस्ट्रियलाइजेशन हुआ नहीं है, कॉम्प्लेक्सिटी नहीं पता है, तो बहुत सारे थोड़े थोड़े बेकार से पेटेंट्स भी पब्लिश हो जाएंगे, एक्सेप्ट हो जाएंगे. Not everything will see the light of the day in terms of market acceptance. So those companies would die out. Their inventions, the rate of inventions of those companies now vanishes. Therefore, there is a kink. Had all those companies been continuing to invent, this trend may have gone up like this. But some will fail. Therefore, the trend falls. Once a few inventions, once a few paths are cleared up. So initially, problem दिख रही थी. इसको approach करने के लिए there were 10 different ways that people were talking about. ठीक है? After some time, we saw that, okay, some of them will not be there. Only 2 or 3 paths will finally be production. So now on these 2-3 paths, many companies would start to innovate so that the value of the main parameter of value increases. Okay? And that is where the number of patents start to rise again. After some time, what happens? After some time, okay, now you do not need as many patents because the art is very well known. You're only improving the MPV slightly. So the number of patents would fall. In the fourth stage, number of patents would actually fall very, very fast. In terms of level of inventiveness, initially, when you're in stage 1, the kind of patents that are submitted or that are filed would have very high level of inventiveness. They will be seminal in nature. They can completely change the face of the product. However, the level of inventiveness in the third stage is progressively very low. Many patents are simply about optimizing. Many patents are simply about solving secondary and tertiary problems that are existing because the engineering system is primarily stabilized. Only very little problems exist जिनको आप solve करने के लिए आप patent करवा रहे हो. And in terms of profits, until you reach stage 2, you are loss making. After you are in stage 2, significantly deep into stage 2, you start to make some profits. Stage 3 is the time where you are reaping the benefit of the invention. So stage 3 में जब आपके पास sufficient profits आ रहे हैं, that is when you start to invest in the next S curve. Let the profit of your past invention feed or sponsor the R&D of the next MPV evolution. Is that okay?
Sir, can you explain the level of invention curve again?
Okay, level of invention can be said as, is this a breakthrough invention? That अगर इस वाली invention को किसी ने use नहीं करा, तो product is not even possible. That is highest level of inventiveness. Then there are other inventions that, okay, the problem is already solved, but I am trying to solve it in a different way. By solving it in a different way, I am improving the performance by 5%. This 5% gain in performance is not significant enough. And there was already some solution that was existing. You're just improvising it or giving a little alternative around it. So the level of inventiveness has gone down.
Right, okay. Because since the slope is decreasing in the, number of inventions or the MPV, as you're going up in the second stage, then we can say that, okay, level of invention is slowly, but it is sort of decreasing like that.
Yeah, see, number of patents reduce इसलिए भी होते हैं because आपको पता लग गया है कि आपको अब next MPV पे focus करना है. So you allocate your budgets on the next MPV. You start to focus on the next MPV, जिसका ये first वाला stage यहाँ पे आएगा, तो उसके अंदर की ये inventiveness वालों को आप यहाँ पे focus करोगे. You will allocate more budget to these than to these inventions.
Right, sir.
है ना? Because when the level of inventiveness is high, even if आप product को market में नहीं लाए, आपके patent की वजह से आपको royalty मिलेगी because the product cannot be implemented without using your patent. Qualcomm, for example, Qualcomm innovated on CDMA. Qualcomm innovated on CDMA when everyone else was still working on GSM. The kind of patents Qualcomm has, no CDMA phone can be made without Qualcomm getting a royalty out of it. So that was a strategy. That we focus on high in level of inventive patents, so that even if someone else, even if say ST Microelectronics or TI or someone else is making a product related to CDMA chip, they are paying a royalty to Qualcomm.
Right, sir. So steady profits in the third stage.
Yes. So when the level of invention is high, it means you are kind of creating a market standard. Your work is seminal in nature. आपके पेटेंट की वजह से ही आपने पूरा का पूरा इंडस्ट्री ओपन कर दिया, एक प्रोडक्ट लाइन ओपन कर दिया, काइंड ऑफ. ठीक है? So when we talk of it in terms of, so this is okay, that was S curves, kind of that there are S curves which will be followed. If you notice in that chart there, just after the S curves, the thing that was below it was trend of increasing value. What does this mean? This means that on the S curves, you can also plot the trend of increasing value. Let us look at it like this. In the first stage, you're trying to increase the functionality and reduce the costs. Okay? You're just working on prototypes. What are you trying to do? The first car, it used the wheels of a horse cart. It was trying to increase the functionality by putting in that motor there, so that horse की जगह आपका एक engine रहेगा, कुछ काम होगा. but it tried to reduce the costs also somehow, because prototypes banane hain, just picking up existing stuff from wherever. When you arrive into the second stage, when you arrive into industrialization, then you say, why do I want to? Because now the product is kind of seeing traction in the market. Let me go to a very efficient product. So I'm increasing the functionality also. And in the process, the cost is also increasing, because I am putting some time and energy into improving the overall material there. Okay. After some time, when the product has stabilized, costs become stagnant, and you're just little by little increasing the functionality. Finally, functionality becomes constant, and the only way to stay in the market is reducing costs. This is the stage when we say that something has become a commodity. Okay. In the fourth stage, you say, I want to reduce the functionality. जैसे मैंने कहा, touch screen नहीं चाहिए. I want feature phone, and you want to increase the cost much more, so that you can still be relevant in the market. And while you are in this, while you have entered into the commodity market in one MPV, you start to work on the first stage of the second MPV that you want to evolve. Now, can you relate this knowledge to your entrepreneurship ventures also? Who can do that for me? हम इनिशियली क्या करते हैं? We talk about MPV, MVP, minimum viable product. Yeah, please. कोई कह रहा था ना, कुछ बोलना शुरू हुआ था, मैंने बीच में टोक दिया. Please.
No, sir. I was just asking if after you're done, can you repeat the last point, because I got disconnected, so that sort of missed the last point you said before you asked the question that if we can relate it to any entrepreneurship venture.
So I was simply saying that in the fourth stage, the functionality is reduced and the cost is reduced significantly. Right. But before you enter the fourth stage, you start to work on the evolution of your next MPV. Yeah. So अब बताओ, entrepreneurship के terms में how will you relate these stages?
We may be doing that during benchmarking, I suppose. No, or trimming even, actually.
अरे MVP, minimum viable product, आप क्या कर रहे हो? Minimum viable product में आप सस्ते से सस्ते तरीके से एक viable product बनाने की कोशिश कर रहे हो, नहीं?
Right.
Demonstrate करने की कोशिश कर रहे हो. आप functionality add कर रहे हो. आप यूजर को एक सर्विस दिखा रहे हो, एक फंक्शनैलिटी दिखा रहे हो, बट इन द मिनिमम पॉसिबल कॉस्ट. तो उस स्टेज में आप उस समय आप फर्स्ट स्टेज में हो. नाउ वंस योर प्रोडक्ट इज लॉन्च्ड, देन व्हाट डू यू डू? You hire new engineers so that they can enhance the functionality of the product. Your costs increase and your functionality increases at a faster pace. It happens. Subsequently, with the same team, you now start to increase functionality further. After some time, you will see that you do not need that many engineers to work on that aspect of your app or that aspect of your product any longer. So you reallocate those engineers to another R&D activity. So you somehow reduce the cost and say, now I only need maintenance to be done on this feature. After some time, you can actually say, this feature is now such a commodity. Yeah, the surroundings, other apps have come, surroundings have evolved in such a way that this feature is no longer needed. I can actually trim the feature, and I further reduce the maintenance costs there. Are you able to see this?
Yes, sir.
So you will realize that any engineering system, in fact, any business system also, any human development system also, this kind of trend is followed. That we all want to increase the value that we bring to our organization. है ना? Wherever we are, we want to be better, na? Anyone who wants to be worse than yesterday? Like, all of us want to be better, and that is what is reflected in this trend of increasing value. Any questions?
So the fourth stage we enter if we want to do some cost cutting. So like if
Yes.
we say that, right, I mean this particular MPV of us, it's way above what is already available in the market. Through benchmarking, we got that. So like, okay, we can afford to cut it down a little so we can focus on another MPV, which will just increase our market value and decrease our cost.
So let me give you another example. Let us say there was a company that was designing MP3 players. Apple की बात करते हैं. They came up with this MP3 players, iPods, long back. So the first iPod, when they came to the market, they captured the market. They were increasing the functionality. iPod के multiple versions आए, and they were maintaining the team to be such. After some time, the functionality starts to remain constant, and they started to reallocate the team members who were working on iPod to iPad teams, for example. But now today, Apple का जब भी कोई event होता है, they don't even talk about iPod. Have you noticed? There's nothing about iPod that you hear from Apple. It is still selling in the market, but no one talks about it. So what do you say? Oh, it is already stable. I don't want to have any more functionality addition. In fact, iPod mini आ जाएगा. उसको देखो, iPhone का. iPhone SE आना शुरू हो गया. 3 साल पुराने वाला जो फोन है, उसको अब आप iPhone SE के नाम मॉडल से लॉन्च कर देते हो in markets like India. Old body, old form factor, old everything, just new chip has been added. So even though today iPhone has a screen size of 6.2 inches also, iPhone SE has a screen size of 4.2 inches. Cost is majorly reduced. Are you able to see this?
Right, sir.
So it's not that आप product को हटा ही दोगे. आप in fact, this is the fourth stage of iPhone there. उसको भी आप market में ला रहे हो. उसके लिए भी takers हैं. ठीक है? Does this clarify? Anything else? Any other questions?
So how is that fourth stage? Because for example, if we're just talking about iPhone SE, right? So now when we are bringing it back, we are keeping it the same, just adding, for example, like you said, we just added a new chip, right? So that's still the third stage only, na? That now you're not.
Third stage तुम देखो, third stage is iPhone Pro, iPhone 13 Pro with 3 cameras, with the flashlight, with autofocus and everything. iPhone SE को देखो, iPhone SE के अंदर तो 1 ही कैमरा है.
Okay, so in this graph we are cutting across multiple. It's more about the product that the company is selling.
Yes, yes,
right. Okay.
yes. है ना? So कभी भी आप देखोगे तो suppose इसी को अगर इकोनॉमिक्स में आप देखोगे तो इकोनॉमिक्स में ये कहा जाता है कि when a product is just launched, the cost of the product is very high. Over time, its cost reduces, and therefore over time the profits of the company improve. But initially the profits of the company are very thin because the technology is new, it is maturing, there are defects, there's effort that needs to go into correcting those defects and so on. So cost is increasing. We are in the stage 2. Once the product matures, market becomes stable. That is when you enter into stage 3, and that is where you start to reduce costs to improve your margins. ठीक है? So that is the trend of increasing value. Let's go back to the initial graph and look at, I will just give you a quick glimpse of other trends also once. So trend of transitioning to a super system, इसको अभी हम थोड़ी देर में देखेंगे. Then trend of increasing completeness of system components. And इसका subtrend है trend of elimination of human involvement. So you will realize that more and more as systems evolve, automation increases. ऐसा होता है? So how is the automation increasing? Because the system is getting more and more complete in itself. If you look at cameras of 10 years back, 20 years back, there was a very strong element of doing the focus on the camera. Today, autofocus is the norm. There is flight of light technology and so many things that human involvement in bringing about that focus is no longer needed. Automatically आपके phone cameras में faces के ऊपर अपने आप squares आ जाते हैं कि भाई the camera is focusing on these 5 faces. These 5 faces will remain in focus. The smiles would automatically shine out. Have you seen that? So human involvement in focusing the camera has reduced, and you will see everywhere automation will naturally happen. अगर आप किसी product की बात भी कर रहे हो, तो the number of clicks that you may want a user, a visitor to make, you want to reduce those clicks. You want to do as much of the analysis in the backend. Instead of searching through 20,000 dresses, you want to use the previous purchase history or previous browse history of a given customer to promote already existing or to promote some particular products to this particular customer, so that human involvement or human search or number of clicks that the customer does reduces. So do you see this? Are you able to understand, appreciate these trends? Hello?
Yes, sir.
Yes, sir. Yes, sir.
Then we will look at the trend of increasing dynamicity in a little while. Let me also talk to you about trend of uneven development of system components. So this is something like जो हमने जो पहले बात करी कि सबसे पहले आपने एक CPU की frequency को बढ़ाया. So when you increase the frequency of the CPU, what happened? Memory frequency did not increase. Memory frequency was increasing at a very slow pace. So what did you do? You started to put in cache hierarchies. So you have L1 cache, L2 cache, L3 cache. So what happened? One part of the system developed. It created the need for another part of the system to develop. And that was when the other part of the system developed. And subsequently, overall throughput of the system improved. Are you able to see this? So this trend of uneven development of system components actually talks about trend of increasing coordination. First, CPU speed increased, then you wanted to coordinate and improve the speed of memory also along with it. So you added caches there. Trend of increasing degree of trimming. What do you think this would mean? This is simple. You know trimming. So what would this mean?
So we are trimming
trying-
to remove the harmful functions and also reduce cost.
Lavanya?
So I was thinking like going more towards the radical trimming side of things, like if we can implement those techniques there.
So both would happen. What it says is that you want to reduce cost. See, once the functionality become constant, once you are in stage 3, the only way to increase your profit margins is by reducing the costs. So you have to trim components. So trend of increasing degree of trimming will naturally be there. Then trend of optimization of flows. So as you're operating your systems, what happens? You will realize, oh, there is friction here, there is friction here, there is an edge here, there is an edge there. You would streamline those things. किसी भी organization में ये होगा, किसी भी engineering system में ये होगा. So trend of optimization of flows will be there. Wherever there is a bottleneck, you will want to increase the bandwidth and remove that bottleneck. So trend of optimization of flows is also a trend that is normally there. What we will do now is we'll spend just a little more time on trend of evolution to a super system. Yes?
So can you please explain the increasing coordination with the uneven development part once more?
Okay. Let me repeat the same example. and then we can see अगर कोई और example देने की need है.
Okay. Okay.
You want to improve the throughput of your computing system. So what did you do? You started to improve the performance of your logic and the processor speed. Now the processor speed improved from 100 megahertz to 2 gigahertz. Now the processor speed has become 2 gigahertz, but your DRAM, the main memory, the SDRAM that you have on your chip, operates at only 500 megahertz. So what do you need to do? To be really able to give the user a good experience of using your system, you need to add cache hierarchy in there. So what have you done? आपने पहले CPU को evolve करवाया. After that, to benefit from the complete evolution of the CPU, you started to evolve the memory subsystem also. So different parts of my system, engineering system, are developing at and evolving at different pace. But they are evolving so that they become more and more coordinated. Memory subsystem was added so that it can match up to the speed of the processor there. So this is the trend of increasing coordination through
Got
the
it.
trend of uneven
Got it.
development of system components.
Got it, sir. Thank you.
So now what we look at is trend of transition to super system. What that trend says is that, okay, so this is more about trend of increasing value, that this was the old computer. And today you have computers like this. With a completely new value proposition you are giving. I'm able to, mark this on the screen of my computer. वहाँ पे हम punch cards के through computer को feedback inputs दिया करते थे. यहाँ पे I'm able to actually put something on the screen of the computer. The computer can actually take many different shapes. So the value has increased over time. Trend of transition to super system. So some time back, you used to have a printer, you used to have a scanner, you used to have a what do you say, or fax. So this was the fax, scanner, and printer. The super system was office workspace. Today you have an office all in one, which does the function of fax, does the function of scan, and does the function of printing also, all in one. So an office which had 5 different components in there today has just one product. So, and this one product does everything in one go. So this is called as trend of transition to super system.
So how is it a transition to super system?
So आप ऑफिस के अंदर देखो, अगर आप ऑफिस के कंपोनेंट्स बनाते, आप प्रिंटर की बात करते, तो आप कहते कि प्रिंटर के विसिनिटी में there is another system which is a super system component, which is a fax machine.
Right. So
Printer की vicinity में there is another super system component which is a scanner.
Yeah.
So these are super system components for the printer at a point of time.
Right.
Printer has evolved to merge them into itself.
All right. Yeah.
So the printer has now become the super system now. It does all those functions by itself. Let us look at the law of increasing dynamization. What it says is that any system would move from, say, a monolith to a single joint, to multi-joint, to elastic, to powder, to liquid, to gas, and finally to field. Okay? And look at this. You first had a simple ruler, then you also have folding rulers. So multi-joint wali cheez aa gayi. You have a measuring tape which is fully elastic, and you have laser rulers also today. Are you able to see this?
Yes, sir.
Can you see similar, let us say talk about beds. So you realize initially बहुत पहले एक monolith तख्त पोश करके bed हुआ करता था. Then what happened? Then you talked about a bed which would have boxes in it and which you could open. So you started to add joints. पहले एक बॉक्स था तो एक जॉइंट हुआ करता था, देन मल्टीपल बॉक्सेस बने तो मल्टीपल जॉइंट्स आ गए. Then you also see hammocks there, an elastic bed. You've also heard about water beds, inflatable beds. You realize all these versions of beds coexist even today.
Yes.
Yes, sir.
And do you also realize that probably the hammock arrived before this multi-joint bed came, or the inflatable gas inflatable bed came before the water bed came? We still do not know about a powder bed yet. We don't know. No, beanbag is a powder bed. Huh? Are you able to see this? So even though this is the trend, it is not necessarily the sequence there, but all these exist. Are you with me? Are you able to see this?
So by saying that they exist at the same time, what are we trying to say? Like at that point, what are you trying to say?
I'm trying to say that कि ये ट्रेंड एग्जिस्ट करता है, उसका मतलब ये नहीं है कि आपका प्रोडक्ट इनवैलिड हो जाएगा 3 साल में. Your product may still be relevant.
Yeah.
Your
Depends
innovation may
upon the
still be relevant.
Depends on the
Don't-
market we are marketing to.
Exactly. So the value that you bring to a particular set of customers is very different.
Yeah.
A hammock, अब तुम रोज hammock में तो नहीं सो सकते ना.
Yeah.
You want a monolith or a joint or a multi-joint bed to sleep every night. Okay, sometime you can sit on the powder beanbag wala chair, but finally you need a regular chair.
Yeah.
है ना. Inflatable bed आपको खाली travel के समय काम करता है. ये जो water bed है कभी कभी काम करता है, रोज तो water bed में नहीं सोने वाले आप. Example के तौर पे, है ना.
Yeah.
So the systems would evolve like that, but the market acceptance may be slow or may not even be there.
Got it.
And your earlier products may still be valid. So this is about innovation. Innovation would happen, inventions would happen, they would bring new products to the market, but old products do not necessarily become irrelevant. Old products do not necessarily become irrelevant. Are you able to see this? है ना. इसी स्केल्स की टर्म्स में प्रोबेबली ये फोल्डिंग रूलर आज इतना नहीं यूज होता, बट ये वाला रूलर तो यूज होता ही है, ये वाला रूलर भी यूज होता ही है, और जगह जगह पे ये वाला रूलर भी यूज होता है ना. So with that, we kind of I would want to close the topic of engineering system evolution. Is that okay? Any questions? Hello? Okay, I assume no questions. So if there are no further questions on this, I would want to talk about something very different then. So I would want to talk about something which is way beyond this class and much more relevant to all of us in terms of life. Ready? You want to listen it out?
Sure.
Okay. So let me ask you one very simple question. When I talk about environment conservation or environment preservation, what are the typical topics? What is the typical dialogue that happens? You would hear about climate change. You would hear about global warming. You would hear about water conservation, air pollution, and so on. Am I right?
Yes, sir. Sustainability, all those conversations.
All those things, recycle, reuse, all that.
Yeah.
But there is actually a much bigger crisis that is unfolding right here, right now, which most of us are not even aware of. That crisis is extinction of soil. So यार हमने एक्सटेंशन ऑफ एनिमल्स सुना था, टाइगर एक्सटेंशन सुना था, जिसके लिए हमने वो नेशनल पार्क्स और वाइल्ड लाइफ सैंक्चुरीज बना दी. ये एक्सटेंशन ऑफ सॉइल क्या है? Extension of soil is that because we are not taking or we have not paid sufficient attention to it, soil is becoming sand. Soil means something which has organic content in it, but the organic content in our soil is reducing at such a rate that it is becoming sand. Sand means desertification is happening. Do you know that a good agricultural soil should have 5 to 6% of organic content in it? And then if I tell you that more than 50% of agricultural soil in the country has less than 0.5% organic content in it, what are we talking about? We're talking about the fact that most of the agricultural soil in the country will no longer be able to produce crops after some time. In fact, UN bodies, World Food bodies and those, they did an analysis, they did a study, and they said that for India, for example, about 60 to 70 harvests are remaining. How many harvests do we do in a year? In North India, we do 3 harvests typically, is it not? So, agar 50 to 60 harvests or 70 harvests are left, how many years are we talking about? We're talking just about 20 to 25 years. So, in next 20 to 25 years, our soils will no longer be able to be agricultural, fertile for agriculture at all. So, see, आज तक जब भी मैं environment की बात करता था, climate change, global warming, sea levels rising, all those things, I always used to think that I am talking about this because it is about future generations. And that future generation did not even mean my children. Forget about you guys. It was not even my children. It was about मेरे बच्चों के बच्चे. उनके लिए मैं ये environment की बातें कर रहा हूँ, है ना? Global warming नहीं होनी चाहिए यार, नहीं तो देखो मालदीव डूब जाएगा. But when I came to know about this soil extension problem, I realized, अरे भाई मालदीव तो जहाँ है वहाँ है. आज से 25 साल बाद मेरे पास खाने का क्राइसिस आने वाला है. See, the population is only going to increase, is it not? We're going to be 9 billion people, 10 billion people by 2050. But what is being said is that the production of the food production is going to fall by around 30% in that time frame. So what are we looking at? Food production is going to fall by 30%. Population is growing up by 50%. We are heading towards a humanitarian disaster. Are we not?
Yes, sir.
We are looking at a humanitarian crisis where people will die because of hunger and famine. And no one of us is ever talking about it. We're all talking about environment. बहुत happy होकर environment की बातें करते हैं, but no one of us is even talking about this crisis, which is a humanitarian crisis, which all of us are going to face in our lifetimes. We're happy talking about something else, which probably we will not face. We may, probably not. A much bigger crisis is unfolding here. So what do we do? How many of you have heard about Sadhguru? Can you just raise your hand?
I have heard. Recently, he's going on this 30,000 bike trip to raise awareness about this. I just saw that today.
Yeah. So Sadhguru is a yogi, a mystic, and socialpreneur, I would say, and he has worked a lot on environment conservation. He is a Indira Gandhi Paryavaran Puraskar awardee. He's for Project Green Hands, where they planted millions of saplings, which are now trees, and completely greened Nilgiri area where their ashram is. He's initiated the Rally for Rivers campaign. after and gave policy documents to the government of India. Today, the government of India has identified 13 rivers where that policy document will be implemented to recover those rivers. He then also launched Kaveri Calling campaign, where millions of saplings, millions of trees are being planted. Entire agricultural is being converted into tree vegetation-based agriculture, tree-based agriculture. So he has a history of working towards the environment, working for the environment. And he is creating awareness about this through a bike rally. Bike rally means only a lone rally. He is the only biker there. And he will be riding from London to Kaveri Basin. He will be reaching Delhi around 5th of June, which is the World Environment Day. And we may have some event over here in Delhi also at that time. But he's going to ride his bike for 100 days. He'll be riding 30,000 kilometers, London to India. And in that process, he will cover more than 25, 26 countries. And as he will be riding through these countries, he will be talking to heads of states, he'll be talking to environment ministers, whoever is relevant, and he will be telling them about this crisis that is unfolding. See, we do not really know about this crisis, and no one is talking about this crisis in common language because we are still getting food. What we do not realize is that the nutrition in that food has also fallen significantly. There have been studies which show that if you would eat an orange in 1920s, so if your great grandfather ate an orange in 1920s, जो न्यूट्रिशन उनको उस एक ऑरेंज से मिलता था, आज अगर हमें वही न्यूट्रिशन चाहिए तो हमें 8 ऑरेंजेस खाने पड़ेंगे. How many of us would ever eat 8 oranges in one go? मैं तो नहीं खाता. So practically none of us will get the same nutrition which our great grandfathers used to get. So this crisis, but no one is talking about it because हम orange खा रहे हैं, हम कह रहे हैं 1 apple a day, keeps the doctor away. That adage is still assumed to be valid, but that's not really valid because the nutrition has dropped. So things are happening, but no one is talking about it. So Sadhguru is going to is taking this rally, 30,000 kilometers, and he's 65 years of age. See, for us, when I drive to campus, I don't stay in campus. When I drive to campus, it's a small distance, it's a short distance. But after that, I feel tired. For many of you, your parents would be driving or would be riding or would be traveling some distance on a daily basis. And after that distance, you know that they are tired. Sadhguru is 65 years of age. Elder than me, elder than most of your parents also, I believe. But he will be at an age of 65. He's committing to ride 30,000 kilometers for 100 days. And, when he was starting, he made a statement which is telling in itself, even if I don't make it, you guys should commit that you make it happen. So he knows that he's actually putting his life at stake. It may not happen, but he says it is still so important, a generational responsibility that all of us should make it happen. So what is it that we should make happen? So what Sadhguru is saying is that we are not looking at stopgap arrangements. We're not looking at यहाँ पे organic farming कर दो या वहाँ पे water harvesting कर दो या यहाँ पे ये कर दो. We do not know what needs to be done. What we are saying is that political parties and governments across the world should look at soil conservation and the problem of soil extinction head on, and should define policies so that this trend, this degradation of soil is reversed. And for that, this awareness campaign. The target is that we should reach out to 3.5 billion people and tell them about soil extinction. You would ask, why 3.5 billion people? 3.5 billion people because in democracies, number of people is the currency that people talk about, that the parties talk about, that the politicians talk about. You remember the term vote bank. So the number of people is the vote bank. So currency is number of people. So 3.5 billion people means 60% of the world electorate is aware of this issue. And they then tell their governments, tell their political parties to make it a mainstay of their manifestos. They want the governments to define policies so that soil is conserved. Now, the policies may be very different in India and they may be very different in France because the climate is very different. The soil type is very different. The cropping patterns are very different. So there is no one solution that is being proposed. In fact, the whole book, a chunk of, so many solutions is being given to UN so that each country can choose the policies according to what fits their needs. But what is most important is every country should do something about their policies. See, when I said that in India, more than 50% of soil has less than 0.5% content, the crisis is not just in India. Even in Europe, more than 70% of soil has less than 2% organic content in it. In the US, more than 60% of soil has less than 1% organic content in it. So the numbers are shocking across the world. So it is not just an India thing, it is a worldwide thing that soil needs to be conserved. If it is not preserved, then and the soil is allowed to become into sand, it will take 100 to 150 years to recover the fertility of the soil back. Abhi, because there is some organic content already in there, even if it is 0.5%, it can still grow and it can be recovered. Once the organic content vanishes, then it is sand. To convert a desert into a fertile land, it's a huge amount of effort and cost and time. And humanity would not have 150 years without food, cannot survive for 150 years without food. So if we say that soil is becoming extinct, then the humanity as we know it today will also become extinct. It's a big crisis that we are looking at. So what do we do? The call for action for us is that we become friends of earth, earth buddies, Mati Mitra, friends for the soil. How do we do that? You can visit this website, savesoil.org, or you can simply give a missed call to this number that I'm just telling you, 800003003. That is 8 4 times 0, 3 3 times 0, 3. So when you go to this website, savesoil.org, you can click on the join button there and you can become an earth buddy. Or you can give a missed call. You will get a link in your phone as an SMS, and you can click on that link and you can become an earth buddy. Once you become an earth buddy, what happens? You will be given, for example, some tweets that you can amplify. You can yourself tweet about Save Soil. You are on Instagram, then Instagram posts will be given to you, which you can amplify, which you can again create your reels. So for example, I created a reel with my family over the weekend where I wanted to create awareness about Save Soil. So you can create reels, you can post them, the basic thing is create as much awareness about it as possible. And the intent is, we're not asking you to spend more than 10 to 15 minutes a day. 10 to 15 minutes a day is sufficient. This guy Sadhguru is spending 100 days on his bike, riding from London to India. He's doing that. For you, he's only asking 10 to 15 minutes a day. But just those 10 to 15 minutes a day can make a big difference, because your 10 minutes a day can reach out this message to 10 more people, 100 more people over time, 1,000 more people over time, depending on how many contacts you have. And in the process, we will come closer to that 3.5 billion number that we are looking at. So I wanted to talk to you about it because I felt that this is a big crisis that each one of us should pay attention to, should do something about. And I would request you, urge you to become Earth Buddies. Give that missed call now, go to the website and click on the join button now. Please do that. This is only, see, Sadhguru is 65 years of age. He is not going to suffer because of the crisis that we're talking about. He will probably not be alive when this soil extinction will actually happen. So he's not doing it for himself, frankly. We should realize that he's doing it for us. He's doing so much. All that we need to do is spend some 10 minutes on Twitter or Instagram, which we already do probably. Just those 10 minutes, but in a focused manner so that we create more awareness about Save Soil. So if you're willing to do it, I would request you to please join the Safe Soil movement as a Earth buddy and do your bit in saving the future for the humanity. Any questions, please? Yeah, Meher, in fact, I also had no idea about it. And when I came to know about it, I was shocked and I was driven enough that I'm talking to all of you about it. So you can talk to your family about it. You can make them Earth buddies. You can talk to your friends about it. You can post on your batch WhatsApp groups. Explode karo yaar is message ko. It is such a huge thing that is happening, and we need to take care of this. Any questions? So how many of you already did that missed call thing? Just raise your hand, or the join button on safesoil.org. All of us do multitasking. I know this, huh? Okay, some of us have already done. Thank you, guys. I would request all of us, please do it. And it's important. It's important for us and for the future of humanity. And it's our responsibility as a multi-generation thing. I'm not a newer generation. I know I'm much older than you, but it is our generational responsibility that we take care of this. So with that, if there are no further questions, I would like to close the class. And if there are any questions, please feel free to ask.
Sir?
Yes, Amir.
I have a question, but वो class से अलग है and Safe Soil से भी अलग है. Class के बाद can we have a short meeting if possible?
Okay, we will do that.
Thank you, sir.
So thank you, friends. I will